Okay, we're recording.
Okay. That's step 7, and is it just step 7 we're doing today, or step 8 as well?
Let's see. I was actually yesterday under the impression that we're supposed to finish up to step 8. So I think I told everybody that.
All right, I'll start. Okay, I'll start reading step 7.
Okay.
Unhard code the machine code. In cpu.py, the ls8 programs you've been running so far have been hard-coded into the source. This isn't particularly user-friendly. Make changes to cpu.py and ls8.py so that the program can be specified on the command line like so. Python 3 ls8.py examples / mult.ls8. The programs print8 and mult are provided in the examples directory for your convenience. For processing the command line, check out sys.argv. Try running the following Python program with different arguments on the command line to see how it works. Note that sysargv at index 0 is the name of the running program itself. If the user runs the following, the values in sysargv will be sysargv at index 0 equals ls8 and sysargv1 equals examples mult. So you can look in the sysargv index 1 for the name of the file to load. Bonus, check to make sure the user has put a command line argument where you expect and print an error and exit if they didn't. In load, you will now want to use those command line arguments to open a file, read in its contents line by line, and save appropriate data into RAM. As you process lines from the file, you should be on the lookout for blank lines. Ignore them, and you should ignore everything after a hashtag, since that's a comment. You'll have to convert the binary strings to integer values to store in RAM. The built-in int function can do that when you specify a number base as the second argument.
All right, let's stop there and let's see if there's any questions on this particular part. Can somebody give like a summary of what we're doing here? Step 7, please. Pretty please.
This is kind of what we just went over, like what you did speedster style in class.
Speedster style, yeah.
It was really quick
He
to
goes
follow.
pretty fast.
Yeah. But this allows us to take in any of the file names or the different files in our examples directory and put them in the argument so that we can print them out and see the result in the terminal.
Very good. Can you give like a small overview of like sysargv again, in case some people don't remember? Anybody? I mean, it's right there, but
any argument passed in when you run the file. Well, it's really any argument passed in once you call Python.
So in that situation, like what would be your sys? Sorry, in that situation.
Sorry, what?
In that like if you're using that example, the Python, this right here, like what is analogous to your sys?
Well, sys would be, I guess, Python 3, and then the arguments would be ls8.py and examples / whatever.
Very good, very good. What else they want you to do here? So basically, like they want you to, handle things dynamically, right? Instead of have to hard code everything like you guys been doing. What about this part right here? What do they want you to do here?
It's just making sure that it's binary, correct? Base 2.
Convert binary string to an integer.
Yeah, like what you said, Hal. he did like int whatever,
Mm-hmm.
and you can specify the base. And before he had it as 2, and they changed it to 10 since it was using base 10 in the instructions. But we need base 2.
Exactly. Okay. Let's see. So, and you guys are supposed to go up to where? Up to step. What step today? Is it at the top here? Day.
I think it's to step 9,
Just
Or-
it's step. Okay.
or maybe just 8, because it says implement a multiply instruction. Do you think it's 8?
Oh yeah. Yep. Okay.
So it's not 9. We don't have to do 9.
Looks like. So it just says implement a multiply instructions. That would be. Yep. That'd be this one. So just step 8 then. Step 9 would be. Oh, step 9 is. I remember that. That's like a stretch almost. Like it just makes your code more legible. Like makes it nicer looking.
Okay,
Instead
so
of like
that's
a
like
ton of these.
optional.
Yeah.
Okay.
Yep. So, but you'll have to like go off and learn on your own what a branch table is. So that's why it's kind of stretchy, because there's nothing in there. Like maybe give you an example, but you'll still have to go do your own research on that. So, yep. So looks like step 7 and 8 are today's MVP. Do you guys have any questions on step 8? Do you want to go over it, or do you feel good about it?
We're just putting the things in the ALU function, like how they have it with add, but with multiply.
Does that make sense to everybody? Yay, nay?
Yes.
Yeah. Yes, Jade, that makes sense? Oh, Beta?
I think so.
You think so? Oh, Beta, you think so or you know so?
I think so, but I'll know so once I try.
Oh, okay. All right. Let's see. Luis, do you feel like you have a good grasp on this?
Yep.
Okay. You want to drop some wisdom real quick on like what your guess is at what we're supposed to do for this step 8 here? Maybe in a very clear way that people that are like that think they know, then we can get them to the point where they have the light bulb. We all can know.
Yeah. So we already know what LDI does, and we already know what print does and halt from yesterday's project. So it's just taking, we're calling LDI at the position of the next item down, R0, and we're passing in the binary value 8. And then the same thing right below, we're calling LDI on the next available RAM spot, which is 1, and we're passing in 9. And then for multiply, we're going to take R0, so whatever the value held there is, multiply it by the value held at R1, and store it in the value R0, whatever that result is. So we'll do 8 times 9, and then store the result in R0, so that when we print right below, it spits out our answer.
Boom. Very good. Does that make sense? Jaden, Obeda? Are we at the we know now? Now you know, like the little rainbow comes across?
I can say yes, but I think it'll just depend on when they get to implementing it. It makes sense though. Thanks,
Okay,
Luis.
yeah, thank you, Luis. Like the idea of what you should be doing, like what is unclear about it? Is it like how this, like it's all zeros, or I'm trying to think of what would be confusing here.
It's not that it's confusing. It's just that going from like it being explained and then actually doing things. That's I just don't know if I'll have any confusions or not until I get to it.
Gotcha. The disconnect. You just got to try it first, right?
Yeah.
Just got to try it. Okay. Sounds like that's it, huh? Anybody else? So, can somebody summarize what the ALU does real quick and what it stands for? Just like a quick little summary.
Where the math happens.
Sounds like a commercial for something. It's where the math happens. The ALU, Arithmetic Logic Unit. Get yours today from Luis's Computers, $29.99. A 2 for $50. Okay, so seems like everybody's got it down. Cool. That was 15 minutes. Or it is 2:15 now. So, all right. We will see y'all at the one-on-ones. Have any questions? Holler at your boy. Probably taking care of the girls. But all right.
Thank you.
Thanks,
guys.
see ya.
Thank you.
Thank you.